For the past month, I've been working on a project that is currently named Pianoplay. Pianoplay is an animation project that can take a MIDI file and turn it into data to be used for animation within Blender. The effect of this can kind of be seen in the last video I released, but I'd like to discuss that video a little bit later. I started this about a month ago after coming across the song Suiren by Sakusho. It's a beautiful song, but it's definitely out of the range of someone like me ever playing it. I lamented about it for a while, but at some point I thought, what if I just made a computer play it for me instead? And so the idea for Pianoplay was born. However, what Pianoplay does isn't really the focus of this video. Instead, I'm going to talk about my thoughts on the project, what I learned, what I want to do in the future, and my problems with it right now. Almost everything for Pianoplay was made within Blender 2.82, and solely by me, Crunchy Duck. The first hurdle was learning to use Python, which is what Blender is made in and what you must script in within Blender. While I do have a coding background, I don't have any experience with Python, and it definitely shows in my code. I had hoped I might be able to cover it up with copious amounts of comments, but in the future I plan on just completely rewriting the code from the ground up. On top of having to learn Python, I had to learn a lot about MIDI files and files in general. To use the data in a MIDI file, it has to be reviewed in the raw format of binary data. As smart as you may be, to understand the binary data stored in the MIDI file, you'll need to find the documentation on it. This was a little harder than I expected. The PDF detailing MIDI specifications is somewhat hidden away on the site that documents MIDI, and requires you to make an account. It also gives quite a foreboding warning that the document was written in 1996. This warning is also present in the document itself, twice. This was not very reassuring, but I never had any problems with the adolescent age of the document. However, the documentation alone is quite dry to read. Perhaps it's because I'm new to this type of work, but I felt like it struggled to explain a lot of the advanced concepts, and the layout of it was honestly quite baffling. For example, delta times are probably the largest part of a MIDI file. Every event in a MIDI file precedes a delta time. But delta times themselves aren't explained until every other concept is explained, meaning there was no way for me to actually test my knowledge on events with code. When it came to the code, I think the hardest part was learning to decode variable length values. These are 8-bit values where the first bit is a flag bit, and the remaining 7 bits are the actual value. If the most significant bit is set, that is the one furthest to the left, then it signifies that there is another byte that comes after this byte that makes up the number that is being stored here. It took a few days to understand it conceptually, and then took a few more days to understand bitwise well enough to program it myself. I couldn't understand the fancy pants explanations that I had found online, so I just thought about it very hard until I had an idea on how I could code something to read these values. And, of course, as any good programmer does, I did it wrong the first time and wasted a day tracking the issue down. Eventually, I built up the framework of code required to read the MIDI file and store the data that I needed. Next, I needed to actually do something with all of this data though, which meant working with Blender's Python API. To be blunt, I think I'm dumb. I struggle to, and still do struggle to understand the documentation, both on Python and on Blender's Python API. I don't properly understand how I can find knowledge I need, and most of the time a random forum is more likely to give me my answer. I'm hoping this is just inexperience on my part though. Working with Blender's API was pretty tedious overall, especially when it came to applying animations. I'd originally hoped that I could make one animation, and then use the data from that animation as a basis for all animations. It was going to be great. It was going to be cross-instrument compatible. It was going to be easy to modify, quick, simple, and good looking. One animation to rule them all. Unfortunately, much like other brands of communism, this one too didn't work. I couldn't find a way to replicate an animation across different points in time. I have a theory on how I might do this in the future, but if anyone does know how to do this, totally give me some information. There's some contact detail in the description of this video. Besides the main Pianoplay script that handles MIDI and the animations, I made a few supplementary scripts to help me while building this. For example, there's one that will name an object sequentially based on the distance to the world origin. After getting a single key to animate in time to the music in Blender, I realized this was very boring. A perfectly white rectangle in the middle of the screen waggling isn't that impressive, so I got to work modelling a better set of keys. At first, I modelled 128 keys, which is the number of pitches that MIDI can support. But I quickly realised that I had never seen a piano with 128 keys, and especially not 128 white keys. After a little bit of research, I cut it down to 88 black and white keys. However, it was still boring. Keys floating around on their own in a void is a tad ethereal. My first idea was to model a grand piano. And as soon as I tried, I realized that this was never going to happen in my natural and unnatural human lifespan. Next, I tried an upright piano. A lot easier, surely. That too didn't succeed, and I learned quite a valuable lesson about how important it is to have a real-life reference. In the town near me, I had remembered that there was an upright piano in the town hall. I considered cycling there to get some photographs, but as soon as it dawned on me that such an act would require me to leave my room, and by extension my house, and then to stand in a public space photographing something while I looked like I was homeless, during a pandemic, I decided against it. Simply, I modelled one of my own electric keyboards. As I'm doing this project for the animation of the keys mostly, I knew that the piano wouldn't be visible and thus wouldn't need to be modelled. Originally, I intended to simply have just the basic frame of the piano, which looked a little something like this. But this too was too dull for me, and so I modelled it almost exactly the same as my real-life reference. I say almost as there's a few key differences. First, my keyboard is not 88 keys long, and so some creative solutions were needed to change the positioning of things. Second, there's a little colour present on the HUD of my piano that I omitted, mostly for my own sanity. There's also some decoration that I didn't bother to add in. When it came to modelling, the hardest part was definitely the speakers, and this shows in just how poorly I modelled them. Anyone experienced with 3D modelling might crucify me for this, but the circular holes are actually made up of somewhere between 20 and 30 vertices, I don't quite remember. This was quite a dumb mistake on my part, as I didn't change the resolution of my cylinder when creating the holes, and I only realised that when I had already put over a day of work into it. Towards the end of the project, I checked to see just how many vertices these speakers were costing me. With the speaker mesh enabled, the model took up 527,918 vertices. With them disabled, it was 98,112 vertices, meaning the speakers alone took up 4/5 of my total number of vertices. Truthfully, I didn't have the motivation to remodel them from scratch by this point, so I got lazy and just used a decimate modifier on them, which roughly halved the total vertex count. After the speakers were done, the HUD was next. The bottom segment is quite easy, just a plain grey colour I created with a material. The top one, however, is solid at the top and striped at the bottom. The resolution of these stripes meant that it would be legally classified as torture if I were to make a human do this, and so I made a Python script to do it for me. I had just prior taught myself about making images in Python for the speaker decor, as one of the materials I needed was a semi-random striped pattern. Adding the buttons to the surface was quite simple, just model one basic looking button, and then use the magic of copy and paste with a boolean modifier to get them into the mesh. The LCD display worried me when I realised that I had to model it. I knew I wasn't going to make my own texture for it as I have very limited knowledge of creating textures from scratch. My first attempt at texturing it was just taking a somewhat neutral photograph of my real LCD display, cropping it, and then slapping it on there like the job was done. It was very bad looking. My image wasn't good for anything. It had shadow, it had reflection, my camera was slightly tilted when I took the photo so it didn't line up. Awful mess overall. However, one of my faithful companions, known only as Oaken, had recently been working in the architecture and design software called Rhino. He saw my frankly shameful display and told me that he would save me from this disaster that I was bringing into the world. After a little bit of communication, he made me a nice and shiny texture that looked scarily accurate. I thanked him and offered him nothing in return but this mention. The shading of the texture was slightly off, so I hue shifted it. To make it shiny, I gave it a low roughness value and moderate specular and metallic value. Ordinarily, you would only set metallic to 1 or 0 to represent dielectric or metal materials. But be quiet, this is art. There are some other interesting materials that I attempted to make besides the HUD elements, but they're not very noteworthy and can't be seen very well in the final render. The text took a couple of attempts to get right. At first I thought about making a real texture for the HUD, but this proved difficult due to the non-Euclidean geometry that is my topography. I considered using text objects to cut into the surface and then simply apply a shader to give it colour. But I soon realised that there was quite literally no reason to do this when I could just take the text and place it on top of the surface. Oaken again helped me by picking out a font that was quite similar to my reference. It is called Corvetica. In the middle of doing all of this, I must mention that my hardware conspired to all die at the exact same time. First, my headphones, which I've had for a little over 2 years now, lost reliable audio in one ear. A few days later, my mouse's middle mouse button completely ceased to work. Taking it apart and inspecting it showed that there was something mechanically broken within the button, and no real way for me to repair it with my lack of tools. This meant that I didn't have the ability to move my camera, and thus had to rebind it to Q. After I had the code and the model down, I needed to make it look somewhat passable. I have a fair amount of theoretical knowledge on things like lighting and camera positioning, but very little practical knowledge. I also didn't expect the scope of this project to exceed keys that were floating in a dark room, so I hadn't prepared an environment to give good quality lighting. I did trial a couple of different lighting environments, but without setting up a fleshed out scene, there was no way I could find to get decent looking bounce lighting. I eventually settled to just borrow the scene from an album cover by Ben Jordan, and to light it with a Rembrandt-like angle and somewhat soft lighting source. I've never made a video in Blender before, as I generally export animations for use in game engines. Because of this, I didn't really know what to expect. When I first attempted to render, it was at 1920 by 1080 resolution, with 128 samples. I did some math, and was surprised to learn that it would take 5 days. After a tiny bit of research, and a little bit more math, I decided to render it at about a third of the original resolution, and a quarter of the original samples. This cut my render time down to only 33 hours. Nice! I set to rendering the first half of this video to get an idea on how it was going to come out, and went to bed. When I woke up, my tired brain thought that I hadn't started the render, and performed another render. This immediately erased what I had done last night. I lamented about it a little to my friends, and was planning on just giving up making this public because I was pretty exhausted by this point. However, they offered to help me with rendering if I gave them the appropriate files. I was a little uncertain on this, but after a second failed render, I decided to try it. Ultimately, I worked with Arix to render this video much faster, and we learned a little bit about tile sizes during it. I still expected it to take a long time, and so I kept pretty low quality settings to minimize the amount of other people's time that I had wasted. I somewhat regretted this later, as it came out looking pretty low quality, and any time I'd put into making special materials for the piano was kind of wasted. Before I finalise this, I'll quickly run through all of the smaller thoughts I couldn't fit in anywhere else. This is, of course, just the first version. I plan to continue working on this in the coming year or two. I'd love to see it in a state where anyone can use it to take a MIDI and turn it into animation, but in its current state, I fear that only I may operate it. If anyone does want me to help them use it for a project, feel free to get in contact with me. There's a lot of stuff I had to cut, or simply couldn't add while working on this, some of which are: I wanted to animate the keys to change colour when pressed, similar to how programs like Synthesia do. I tried to work this in, but I felt I was going to have a lot of trouble trying to work with Blender's API, especially in relation to materials. This is almost certainly possible though, and I want to add it next. I did not add pressure sensitivity to the keys. Even though I am storing the velocity a key was pressed or released at, I had trouble getting the keyframes to function as I'd like, with the variation this would cause, and cut it for the first version. The animations are quite dull. Right now, all motions are linear interpolation. I tried to work with bounce interpolation, but couldn't get it to look very natural. There are still some imperfections in how my code reads and applies animation, I think. While it doesn't throw errors, there's some very strange results I got at certain points in the song which required manual adjusting. I did not animate a sustain pedal. Much like the key velocity, I'm storing this data but not doing anything with it yet. Sustain pedal support will be easy to add later though. The piano isn't fully modelled. I neglected the back and the underside as it's not visible from the camera angle I chose. The render is low quality, which is a byproduct of my inexperience. The lighting and camera angles are quite boring. I wanted to change the camera shot of the piano throughout the song to capture specific parts of the piano in the song, but I didn't this time for my own sanity. The name of this project, Pianoplay, was supposed to just be a placeholder, but I couldn't think of anything else before this. With all of this done, I'm kind of unsure on how I feel about the project. I've started many projects that I never end up showing to anyone, either because I stop before I finalise it, or because I don't think it's good enough to show anyone. I'm hoping this project will act as a first stepping stone to help me break that habit though, and to help start my future. Oh, and I forgot to mention this earlier, but the project is entirely open source. The GitHub containing everything can be found in the description.